Hello everybody, this is the first screencast for Unit 4 Prerequisite Skills 1. I'm going to start with the vocabulary. So we have polynomial. Polynomial. And a polynomial is any expression where terms are added and or subtracted. Okay. Then there's different types of polynomials. So we have monomial or monomial, and this is a polynomial, so as above, but this just has one term. So, for example, 5x would be monomial. So a polynomial, terms are added or subtracted. In this case, we'd be adding or subtracting 0, and we don't really need to write it. Okay, so trying to see. Okay, sorry. So binomial. And obviously, as you can see, the second half of these words, nomial, meaning number, and mon is 1, bi means 2, so this is a polynomial with 2 terms. And an example here, we'll just add on 5x plus 3. There's 2 different terms. Then we have a trinomial, which I'm sure you've guessed by now is a polynomial with 3 terms. Okay, so if we have x squared minus 4x plus 3, that would be a trinomial. Okay, so moving away from your nomials for a minute, we have like terms, which you have heard and used before many times. So like terms are your constants or variables. So like terms could be your constants, which are just your numbers, or they could be variables with the same exponent. Okay, so if you have, example, you could have 10 plus 4. Obviously, those are like terms, we can add those. Or you could have 3x plus 5x, and we could add those and get 8x. But if we had 3x squared plus 5x, I could not add these to get 8x because I have a squared term and a plain old term, which we would know to be the first power. So since they don't have the same exponent, they're not like terms. We just have to leave them be. Okay. Degree of a polynomial function. So I'm just going to write degree. Degree of a polynomial function. This is the power of the term with the highest exponent. So the power of the term with the highest exponent. So if you have 7 minus 4x plus 3x to the third minus 2x squared, this would be degree 3 because the highest exponent is the number 3. General form of a polynomial. So general form is when you write the polynomial, so the degrees decrease from left to right. So writing the polynomial so that the degree degrees decrease from left to right. So again, for example, that last one that I wrote, I don't remember the exact numbers. Let me go back. So if we look here, this would not be in general form. I would have to have my numbers decreasing from left to right. So I'm just going to put down here, here's what general form of the above would look like. I would take each term with the sign in front of the term. So my highest degree here is degree 3. So I'm going to take this whole term, and that would go first. So 3x to the third. I didn't put the plus because it's positive, and obviously if you don't write it, it's positive. Then I look for my next degree. I have squared. So I'm going to take this whole term, which is negative 2x squared. Next would be this minus 4x. And then finally I have my constant term, which is 7, so it would be plus 7. So this would be the general form of that example that I just wrote for degree 3. And this is easy really to see that now it's degree 3 because we wrote the highest to lowest from left to right. Okay, so the last thing on this page is a polynomial function, and it gives you this polynomial function. So I just want to label a couple parts to this just so you have an idea. So we have y equals x to the third plus 9x squared plus 26x plus 24. So here is your highest degree term, like we just talked about. And if the lowest degree term is your constant, then that's what you end in. Otherwise, you would end in the lowest. This whole thing is called a polynomial. And it's a polynomial function because you have the y equals. So this piece right here makes it a function because you now added the equal sign. So alone, it's just a polynomial, but with the y equals, that makes it a function. So moving right along to example A, this is adding and subtracting polynomials. So they're asking us to find the sum and the difference of those two 4-term polynomials. So there's a couple of ways we can do this. I'm going to do sums first, and then I'll go on to differences. So finding the sum, just like when you're adding numbers, you can find the sum horizontally or vertically, and depending on how many terms or how big the numbers you're adding are, usually depend on which way you want to do it. So we have a horizontal sum and a vertical sum. So let me just, for example, if we're just doing numbers, right? If I had 7 plus 3, that's nice and easy, 10. It doesn't really give me any advantage to write it this way. But if I had 562 plus 237, I get my answer, but it's a whole lot easier to add these two if I line them up vertically. 9, 9, 7. And so this is 799. Now, of course, they equal the same thing, but vertical sum is a little bit easier. And when we do the vertical sum, we line it up so that we have, right, our ones column, our tens column, and our hundreds column. So if I was adding a 4-digit and a 2-digit number, we would line everything up accordingly. It works the same way with polynomials. So I'm going to start out with our horizontal sum when we're adding these two polynomials. So we have 2x to the third power plus 6x squared minus 3x plus 9 plus the other polynomial 4x to the third power minus 2x squared minus x plus 2. Now because we're adding, since we're adding here, this set of parentheses we really don't need. We don't even need the first set because adding, we're just adding everything straight across. So I'm going to drop those parentheses. 2x to the third minus 6x squared minus 3x plus 9 plus 4x to the third minus 2x squared minus x plus 2. And here's where we get into our like terms. So I'm going to go around and I'm going to use different colors because I can. You can use different shapes. And we look for what terms are in common. So we have 2x to the third and 4x to the third. Now notice when I circled the 4x to the third, I circled the sign in front because that's going to tell me what to do. So I'm doing 2x to the third plus 4x to the third. And that gives me 6 x's to the third power. On to the next term, I have a negative 6x squared and a negative 2x squared. So negative 6 and a negative 2 come together to make a negative 8x squared. I have a negative 3x and a negative x. And remember, this has a 1 in front of it. So negative 3x plus negative 1x gives me a negative 4x. And I just realized that I copied the problem wrong, so let me go back. Ay, ay, ay. Good thing it's not too far in ahead. This is supposed to be a plus 6x here. I copied it wrong. My bad. So positive 6x and positive 6x and a negative 2x, that would make this here a positive 4x. Okay, sorry. Back on track now. Okay, and then lastly we have our constants, a positive 9 and a positive 2, and that makes a positive 11. We've used all of our terms here. Nothing is left uncircled. And when we look down here at our solution, every single term has a different exponent or no exponent at all as the constant in 11. So we know that this is as simple as it gets, this polynomial. 6x to the third plus 4x squared minus 4x plus 11 is the solution to adding those two polynomials. Now, like I said, we could have done this vertically. So if I do the vertical sum, like I said before, we have to line the terms up vertically. So I have the first is 2x to the third power plus 6x squared minus 3x plus 9. The second one, when I line them up, I'm lining up my variables with the same exponents vertically. Luckily, this one is 4 terms and 4 terms, and all the terms match. So it's not too difficult. So 4x to the third power minus 2x squared minus 1x plus 2. And I add just like I would in regular addition, but I don't do any carrying. So when I add these terms, I just add straight down. So 9 plus 2 is 11. It's a positive 11. Negative 3x minus 1x, remember I just put in that 1 to remember that there is a 1 there, is negative 4x. 6x squared, positive, minus 2x, or plus negative 2x, is a positive 4x squared. And in front, 2x to the third plus 4x to the third gives me 6x to the third. And here's my solution here. So this one kind of already lines up your like terms because you're doing that when you put them together in a inline already, and then you don't have to go through and circle everything. So subtraction works the same way for the difference, except we have to go through and distribute a negative first. So when I do that, we get a horizontal difference Okay, so if now difference is subtract. So I have my two polynomials again, 2x to the third plus 6x squared minus 3x plus 9 minus, and here I have 4x to the third minus 2x squared minus 1x plus 2. So here, there's a couple of different ways you can think about this problem. You can think about, for the second one here, you can think about adding the opposite. You can think about keep, flip, change. Or you can think about distributing a -1. Okay, either way, you have to account for the fact that this is now a negative sign, which makes everything in your second set of parentheses change signs. So when you think about either way, if you add the opposite, you would change your negative in here in the middle to addition, and then change the term, all these terms here. If you keep, flip, change, it's the same idea. You keep the first set of parentheses, flip the sign in the middle from minus to plus, and change all the signs at the ends. Or if you distribute a -1, multiplying by a negative makes every term in the other set of parentheses change to the opposite. So once you've done one of those, whichever one makes the most sense to you, or you'll remember, then we can rewrite this without the parentheses. So I have 2x to the third plus 6x squared minus 3x plus 9 plus, because that has changed, I have -4x to the third plus 2x squared plus 1x minus or plus -2. So now again I go through and I look for my like terms. So I have 2x to the third power and a -4x to the third power. So this is going to give me a -2x to the third power, just adding those coefficients for your like terms. I have a positive 6x squared and a positive 2x squared, which gives me positive 8x squared. I have a -3x and a positive 1x, so that gives me a -2x. And lastly, I have a positive 9 and a -2, which gives me a positive 7. Again, all my terms have been accounted for. Nothing is alike here. So my final answer, -2x to the third plus 8x squared minus 2x plus 7. And there's the difference or the subtraction. Okay, so the vertical difference, same idea. Vertical difference. So I have the 2x to the third plus 6x squared minus 3x plus 9 minus 4x to the third minus 2x squared minus 1x plus 2. And again, here is that negative sign. So if I think about it as a -1, I have to distribute that -1 and change the sign of everything inside. So I'm going to rewrite the top. I would have 2x to the third plus 6x squared minus 3x plus 9. And now the bottom, being rewritten with that distribution, I would be adding -1 times 4x to the third is -4x to the third. -1 times -2 is positive 2x squared. -1 times -1 is positive 1x. And -1 times positive 2 is -2. And now I can add those guys up. 2x to the third plus -4x to the third is -2x to the third. 6 plus 2, that's 8x squared. -3x plus 1x is -2x. And 9 minus 2 is positive 7. And there's the solution there. So that's adding and subtracting polynomials. The next screencast, distributive property and FOIL.